Hi everyone, my name is Yuan Peng. I'm a research fellow at the Institute for Medical Informatics and Biometry in Dresden, Germany. I'm very happy to be here today to talk to you about our work of an ETL process design for data harmonization to participate in international research with German RWD data based on FHIR and OMOP CDM. So all university hospitals in Germany are obligated to provide their data in the core data set defined by German Medical Informatics Initiative R4 FHIR format. For enabling the university hospitals in Germany to participate in the international research using OMOP CDM, an ETL process is necessary. And therefore, this ETL process should be able to transform the MII core data set format to OMOP, and should be able to process a huge amount of data at once. And of course, this ETL process should also be able to cope with the changes in the FHIR format. So our ETL process is implemented using Java and the Spring Batch framework for the batch process. So as you can see, this ETL process has a classic structure of the Spring Batch. The reader reads the FHIR resources and then pass them on to the processor for the transformation from FHIR format to OMOP conform format. After that, the writer writes the transformed FHIR resources to OMOP CDM. And as the final step of this entire ETL process, multiple SQL scripts will be excluded for the transformation on the database level. This prevents, of course, the random access memory overload and guarantee the performance of the entire ETL process. So in order to cope with the changes in the FHIR format, we also implemented a single step function into this ETL process, which means if any changes occurred in only one type of the FHIR resources, the user has to only exclude this ETL process to transform this particular type of resource type FHIR resource again instead of the fully reload. Of course, as the final step is always as the fully load, the SQL scripts will be excluded. But in this way, only the corresponding to this type of FHIR resources will be excluded. And of course, we did performance evaluation on this ETL process using about 392,000 FHIR resources. As the result shows that the post-process step, which excludes multiple SQL scripts, is the most efficient one. As for other steps, it depends on the complexity of the mapping, which means the more complex the mapping, the slower the step. And of course, we did also a comparison between of each step between the single step and the full load. Somehow the performance of each step is in the single step is not quite efficient as it is in the full load, but in the big picture we can see that the transformation time for each single step is still faster than reload the whole resources. So as our next step for the further development, of course, we have to mapping our German ATC code to ArchSNOR, and also mapping our German procedure code to SNOMED code. And until now, our ETL process transforms only the basic modules from the MII CDS, which will be extended to transform the extended modules from this data set, such as the biobank or oncology data. And the performance of the ETL process is still a quite important issue, which will be taken care of, which will be improve it in the future. And for some projects in Germany, they need a daily basis update of data in OMOP CDM. Therefore, we planned to implement also this function into our ETL process, which is already done, and we have published this work in a journal publication. And if you're interested, you can Google it and think the preprint is already out there. And as a conclusion for this whole work, this means our ETL process can be used or can be executed at all healthcare providers in Germany as long as they can provide their data in the form of MI core data set. So I'm at the end of my presentation. If you have any questions or interested in our work or our further work, so feel free to contact us. And thank you for your attention.